Okay, welcome in folks to the Resene Tech Chat number 2. Rob Mountford here with you today, and I was supposed to be sitting in Wellington alongside our technical services manager Jeff Jelena. However, given that the world's been flipped on its head over the last few days, we've gone for the no travel option, and I'm here by myself in Auckland. Shouldn't make too much of a difference to the info we're covering off today. However, we will be without Jeff, sprinkling his expertise across some of the more technical topics. Just to point out, I'm the sales technical guy and Jeff's the PhD technical guy, so there's quite a bit of a difference between the two of us. On a quick note today on registrations for the webinar, they exploded the other day and have maxed us out on participants, and unfortunately, our webinar providers have been inundated globally in recent days as well, and they couldn't upgrade us in time. So some of your colleagues may not be able to log in today. It's not a problem for them though, as they can watch the webinar at a later date, as it'll be uploaded to our webinar library. We will fire out an email to them as well. However, if you do hear any grumblings around the office, can you let them know that we've simply maxed out? And we'll be in touch. So today will be a high-level look at some of the FAQs that we get asked on a daily basis via our technical lines and architectural team. And I'll be trying to go through things in a similar format as to how we'd answer them via the phone or email. Some of the topics today here as well we'll cover off in a lot more detail in future webinars as we roll through the year. On that note, given that most of the CPD events are being postponed or cancelled at the moment, we will be endeavouring to increase the number of webinars we're delivering to the industry, and we'll certainly be making available pre-recorded webinars so that it's more convenient for you to view at a time that suits. It is an ever-evolving thing day by day, obviously, and it may even see us team up with other suppliers. We'll be looking at presentations via Skype and Zoom platforms so that we don't need to do the face-to-face thing with you. But please do have a chat with your Resene rep if you do want to take us up on this, and we'll certainly make it happen for you. For today's webinar, I'll be answering, or I won't be answering, sorry, questions live, as there's a lot to get through, and it's a bit difficult for me to get across to the questions area when I'm flying solo. But please do ask your questions though, and we certainly will come back to you after the webinar. For the types of questions like I can't hear anything, it will be at your end, not ours. So please do just check your mute or your volume buttons. I'm breaking the 101 rule here today for webinars by having a fair bit of text on the slide, so apologies in advance. I'll try not to read it out word for word, and the sections are downloadable in the handouts area, but hopefully that extra text will be useful for you in future. As mentioned, some of the topics today will be covered off in a lot more detail on future webinars. So again, just a reminder, today's info is really high level stuff. And another reminder, we are new to this, so we will get better as we roll through our webinars. For our friends in Australia who have tuned in today, there's a lot of New Zealand-centric info here. However, there will be some areas that do cross over for you. So let's crack into it now. So the areas we're looking at today are LRVs. We're going to recap on those. They come up all the time. Color codes, fire group ratings, paint systems for concrete and steel, and we'll cover off as well exterior timber, particularly clear polyurethane coatings. So LRVs, light reflectance values. Now, many of you may understand these, but we do get a lot of people coming through a little confused about LRVs. Light reflectance values, it's the total quantity of visible light that's deflected from the surface. So what that means is it's the color that you see on the surface. Visible light is only 44% of the energy from the sun. 56 is made up by other parts. We'll go through that in a little later in a few more slides. And the LRV scale is, it's a really simple scale. It's 0 is the darkest color or black, and 100% is your lightest color. So you'll see a couple of examples on screen there of where the LRV scale sits. In our industry, LRVs relate to paint, not semi-transparent or penetrating stains. That's quite simply because paint reflects the light and the stains don't. So where do they sit? So LRVs generally relate to paint color selections for substrates that are affected by heat stress. So you're talking your timbers, fiber cement, cladding, your cement renders. They generally don't relate to solid concrete and metals or substrates that aren't affected by heat stress. Now, one exception there for metals is that where intumescent coatings are used in exterior situations or in exposed interior situations like atriums, typically there is an LRV limit put on the color. Timber suppliers generally require around 45% or greater. Some require 50% or greater now for their cladding substrates. Now, this is a really important point here, is they set their limits themselves. It's not paint suppliers that do that. So you need to refer to the supplier or manufacturer of your substrate to get the LRV limits that are set in place for their products. Some of the newer timber suppliers, so the likes of your Akoyas and Abodos, treat the timber differently with new processes, and they can have greater thermal stability, so their LRVs can be lower. But again, you do need to check with them on their ratings that they advise for their substrates. Thought what we do is just put up on screen here today, just to give you an indication of where colors sit at an LRV of 45%. All of these colors are 45%, so you'll get that they're not particularly dark. Now, the LRV of a color never changes. So when you're using other products, and we'll talk a little bit about Resene Cool Color today, we're not here to talk about products particularly, but we do need to bring up cool colors because it's an area that does create a little bit of confusion out there. The LRV of a color never changes. So Resene Cool Color does not change the LRV of a color. So what are they used for? As I've already mentioned, they're used to restrict paint colors on substrates. Now, it's really important point to note as well, if you deviate away from the LRV guidelines, often and almost always, the manufacturers or substrate suppliers guarantees on their substrates could well be voided. So again, just a reminder, you need to talk to them about what you're wanting to do with their substrates. Well, we've talked about LRVs being the measure of visible light, or the color that's reflected. There is another measurement, and that's total solar reflectance, and that measures the near infrared radiation reflected from the surface. Now, we feel that that's a far better way of or a guideline in the industry. Unfortunately, TSRs are not currently widely used by substrate manufacturers and suppliers or local authorities. They are quite a complicated method of calculation, and so currently LRVs is a very simple way of that guideline being provided in the industry. It's important to note as well that there's no direct correlation between LRV and TSRs. Thought I'd just put up this little chart that shows, as we talked about, visible light, 44% of the energy from sunlight. The other 56% is made up of ultraviolet light and particularly infrared. Now, infrared area is where Resene Cool Color does its magic. Again, just to reiterate, LRV recommendations are set by the substrate manufacturers, suppliers, and local councils, not by us as paint manufacturers. I've already noted this one, but again, I've repeated it. LRV does not change for the color, even when you're using Resene Cool Color. TSRs do change when you're using Resene Cool Color, and they improve. The TSR of the color will improve as it reduces the amount of infrared heat transferred in through the coating and into the substrate. Another really important point is Cool Color is not a silver bullet that fixes everything. It reduces the amount of infrared heat. It does not eliminate all infrared heat transferred through into the substrate. This is just a good representation of Resene Cool Color at work. On the picture on the right-hand side there, the black sample is Resene Cool Color in black, and it performs in a similar area as the sample on the left, which is a light to mid-grey. That's a standard paint color. So those two samples perform about the same when they're on in a cladding situation, or roof for that matter. A really important point for Cool Colors, and this is another one that comes up a lot for us through our advice lines, is Resene Cool Color does not render the surface cool to touch. It's minimizing the amount of heat being transferred into the substrate, but it doesn't render the surface cool to touch. Now certainly for this type of information, Jeff would be taking over here. I'll flick through it pretty quickly, but it's a great representation. It's electromagnetic reflectance curve. Colin spoke a little bit about this in our last webinar, but it's a good representation of how Cool Color works, or where in the spectrum it works. So the top line there that you see is in blue is a standard white, has, as you'll see it, high in the reflectance. Standard black at the bottom in the orange line, and then the grey squiggle through the middle is where Resene Cool Color is doing its work. So over on the left of what we see, that's the color we see, and then of course through the squiggle is there where you're talking about your infrared heat, and that's where Resene Cool Color is performing. And this is just a little bit of info to show you the most popular roof colors and how the improvement is when using Cool Color version versus standard colors, the improvement in total solar reflectance we're talking about here. So just to note as well, as I mentioned at the beginning, stains don't have LRV levels, and occasionally it comes up where you're asked for an LRV of a stain. They don't exist, so what we do is we just quite simply do an estimation where we select the most or the closest solid color to the stain color, and then that's the estimate for the LRVs. So it's a pretty simple process. So really key points here at the end of LRVs is before selecting your colors, you really need to understand what limits are in place for the substrate, and also the local authority. We do get some curveballs at times with local authorities requiring different LRV levels for their environment. Many councils and local authorities do consider Resene, or will consider Resene Cool Color technology in a submission for an alternative solution. So it's really important that you talk to everyone at design stage and directly with the local authorities or substrate suppliers before the project's underway. All too often, we are fielding calls after a project's completed and a property's been painted, and people are needing information from us to get them out of the shtuck. And in some situations, we're not able to help, and residential dwellings, for example, sometimes need to be repainted. So really important that it's covered off at the beginning rather than the end. Right, while we're on color, this is another area that comes up quite often for us, is when we get given, for example, RGB values or CMYK codes. And so we just thought we'd cover this off. And we really want to just point out what's the difference between the 4 that you see there on screen. So Pantone colors, PMS colors are the most common ones that come up for us. And of course, they're the global branding standardized inks in the graphics community. So we see these a lot. And the beauty of Pantone colors is they've got a great swatch book like you see there on the right-hand side. So we get asked all the time, can we tint PMS colors? And it really is a yes or no, yes and no answer. No, we can't, because we don't tint using their inks. What we do is we tint using our paint and tinters, and we have very, very good visual color matches on file, but it's really important to understand that they're close, but they're not exact to Pantone colors. And quite simply, paint versus ink is different as well, so it will look different. So CMYK codes come in regularly as well, and these are used for offset and digital printing. So they're a combination of the inks that you see there, or the color inks, the 4 ink colors, sorry, that you see there on screen, and it's a combination of dots that go to make up their colors. Quite simply, we cannot tint to a CMYK code. So what we're going to do when you fire us in a request like that is probably come back to you and ask you for the Pantone color that it relates to. Almost always they relate, there's a corporate branding project or something started somewhere with a Pantone color. Or it could well be a manufacturer's, paint manufacturers ourselves, Dulux, Wattle, whoever, Valspar, color code sitting in there, color name sitting in there behind the scenes. So we're going to come back and ask you for that. RGB is probably actually the most common one that comes in, and that's, of course, it's an on-screen for digital combination of red, green, blue. Again, we can't tint to RGB codes, but what I'll show you in a few slides' time, what we can do is show you how we get the closest Resene colors to some of these codes that come in. It's a really simple way of doing it, and we'll show you that in a few slides' time. Again, we're going to ask you to draw in and see whether there's a Pantone color sitting in behind the scenes somewhere. Hex codes are lesser, but they do come in at times, and they're essentially just another RGB value. I won't repeat myself, same as RGB for these ones, but they're used in web design. So the key points here is generally when you're given those codes, they relate to a Pantone color somewhere sitting in behind the scenes. We're going to ask you for that one. As mentioned, we've got visual color matches on file for Pantone colors. They're close, not always exact. Our colors are unique, and they do have their own RGB values, CMYK codes, hex codes. Now I'm about to show you, when you ask us for our closest colors, I'll show you the way that we do it, and it's perfectly available to you. It's just on our website. I was going to do this live, but we'll just do it in slides as we go. It's really a simple process. You just click on colors, view a color, find a color, and then you're going to pop up with this screen, and you'll see there on the right hand side we've got RGB, CMYK codes, even hex value there. So you can modify these fields. So you quite simply put your RGB value in, and then click search down on the bottom right hand side, and you'll be shown this screen will pop up, and it gives you our closest colors to the codes that you've put in. Now typically the top left color is the closest, and when you click on that swatch, it'll bring you up the color and all the details that go with the color. And as you see there on the down the middle, it's all our RGB values and CMYK codes. All those codes are formulated after the color's created, so you can't, in reverse, you can't just give us a random RGB value and we can formulate a color out of that. So our colors are formulated, and then we figure out the values. So as you see there, I've put in fairly close field, knowing that we're doing this webinar today and knowing that it would pop up there. But it's a really simple process. what we do recommend is you grab the drawdowns of a few of those options that you see on screen, so you can eyeball it and make sure that the colors are as close as you want them to be. But this is the way we do it, and it's pretty effective finding close colors. Right, we're going to move on to fire group ratings and critical radiant flux. These come up, and in fact, we're dealing with a couple this morning as well. So it appears to be quite a complicated thing, and it's actually quite a simple thing. So we'll just look at fire group ratings to begin with, and typically, obviously, they're for interior wall and ceiling linings. Now, this first note here is really where it's all at. Fire group ratings are determined by the uncoated substrate. So waterborne or solvent-borne paints put on at their normal film builds do not alter the uncoated fire group rating of the substrate. Just to give you an indication, a normal film build of a paint coating is about 120 microns, so 40 microns per coat. And there's 1,000 microns in a millimeter. So at 40 microns is a pretty thin, and obviously at 3 coats are 120 microns. These are the group ratings from the code. Group 1 being concrete and masonry, fibre cement board. Group 2, plasterboard. Group 3 is your timber area. Now, just an interesting note here, or factoid, is that our friends at Winstone Wallboards jib board actually tests in its testing, brings it into Group 1. So what we're looking at here on screen is actually the generic codes from generic group ratings from the building code. So when you ask us for information, this is the page that we will send back to you from the building code. And it's really, really clear and simple, is that the performance is with or without coating. So this always relates back to the substrate's own fire group rating. And the note at the top there says the table can be taken as having performance indicated without the need for further evaluation. What that means is we don't need to give you fire testing reports on the paint coatings themselves. They're simply not required. Now, when you get asked for more, this chart would typically satisfy 99% of inquiries that come in. Sometimes you're dealing with someone who requires more information, and what you would do in that case is you're providing them with this, and you're also providing a Resene specification or a paint supplier's specification, and also your fire engineer's report as well. And that normally satisfies the requirement of the building inspector that you're dealing with. But generally, so this satisfies 99% of inquiries that come in. A little note here on interior timber wall and ceiling linings. Obviously, we've changed now, and often for crowd spaces and egress ways, you need to improve the group rating from Group 3 to Group 2. To do this, you do need or do require an intumescent coating. Standard paint coatings will not improve the group rating of your substrate. So we'll go into intumescence in another webinar in more detail, and we're not covering them off today, but it's really important to understand that you will require an intumescent coating. Often they are, almost always, they are a specialist applicator or approved applicator type of product. So you can get caught out sometimes if it's rolled into your specification and just a standard painting contractors dealing with it. You're more than likely going to require a specialist applicator to put an intumescent coating on. Now, critical radiant flux for flooring substrates is almost the same as what we've just talked about for fire group ratings, so I won't spend too much time on this. So again, the kick is right there in the first note. It's determined by the uncoated substrate, and paint coatings do not alter the uncoated substrate's critical radiant flux. And there are the ratings for concrete, 4.5, for wood products greater than, or solid wood greater than 12 mil is 2.2. Same again, there's a chart that goes along with it that we will provide to you. And I've just realized as I'm looking at this, I should have put these in the handouts area for download as well, and I haven't done that. So if anyone's after these, we're more than happy to send them out to you at any time. Just fire that through in a question and we'll get them out to you. Same info there. Now we're going to have a quick look at exterior concrete and paint systems. And this, of course, comes out of the Code of Practice, Concrete and Masonry Construction Association. Typically, we'll just go back to that. So typically, most of our paint systems that you'll see, we're not making them up as we go. We are always adhering to the guidelines that are provided by the industry standards. There's a couple of definitions that we thought we'd throw in here, and I'm certainly not going to read through these, and I would have had Jeff explaining these, but there's a difference. What it comes down to is there's a difference between something that's waterproof or weathertight. And in simple terms, waterproof or waterproof membrane is impervious to water, moisture, or vapor. Weathertight membranes, which is where our products like X200, X300, X400 sit, allow some level of vapor through them, so they're not fully impervious to that vapor transfer. And of course, weathertight coatings or weathertight membranes play a part, or they're just part of your weathertight cladding system that you have on your dwellings or buildings. So I won't go through that, but there's the difference between weathertight and waterproof. We changed our terminology a few years ago simply for that reason, to ensure we were bang on with the terminology that's required for the coating systems that we provide. Put far too much info in there on weathertight and waterproof. Now we will just have a quick look at the three types of concrete walls, and we're really just focusing on the concrete masonry construction here today, although we've got the info for Insitu and precast concrete. The reason for that is on this next slide here is that typically Insitu and precast concrete provide weather tightness without the need for exterior coatings or plaster, so you don't actually need to paint them. Often people will just put water repellent type coatings like a Resene Aquapel on just to give some added protection to the surface, but in a lot of cases precast and Insitu concrete's not painted, of course. That's another, just reiterating what I've just said there, is specifies the Insitu and precast concrete to be weathertight. Now I will flick through these fairly quickly. These are the designations for each areas. For masonry, A1 and A3 are relevant to the coatings guide. And I'll point out in a few slides where these sit, just so that you're able to identify them. Insitu B1 and B3, precast C1 and C3. So now this is the guide from the Code of Practice, and I'm going to zoom in on these areas that I've highlighted here on the next slide, but I'm just showing you where the designations sit. So there's your A1 and A3 in masonry construction, and we're just looking at the coating systems area for this today. That's a zoom in on those areas, and for masonry specifically, what this is telling you here, and if you look at the middle area, not applicable. Sorry, I'll start again. So at the top, it shows you the different types of coatings that you can select from to apply onto the substrates. So for masonry, the one in the middle there that says not applicable, what that's showing you is a pigmented acrylic coating or a standard acrylic coating at 80 microns or greater is not applicable. What that means is you can't put a standard acrylic coating on masonry. It requires a weather-tight coating system on there, and on the left-hand side, you will see that the pigmented high build coating is required at greater than 180 microns. So that's a standard high build, or an elastomeric high build is required on masonry at greater than 180 microns. In our range, that's where X200, X300, X400 sit. On the right-hand side there, where you see the clear coating column, what's required there is a high build clear coating on there that meets the permeability requirements of the standard that you see there as well down the bottom for masonry. So in our range, that's XC700. Just a quick look at Insitu and Precast. When you see the options that are available there, it's showing you that all options are required. Like as we've said, you don't actually have to paint Insitu or Precast. You could put standard acrylic coatings on there. A lot of people will still put their high build coatings onto Insitu and Precast, and you can put the range of clear coatings on there as well. Now, we're a little cautious when we're using clear coatings onto Insitu or Precast concrete. So I'll show you another slide after this one. This is just a little coatings guide that we put together as just a quick reference as to where you should be looking for your coatings when you're dealing with concrete. On occasion, I've thrown in there non-weather tight Insitu. On occasion, we get requests in that area. And of course, you would just default back to your high build coatings because you will require a weather tight coating if you have non-weather tight Insitu to deal with. So just as I mentioned there, with clear coating Insitu concrete or Precast concrete, it makes us a little bit nervous at times. And the issue that we have is that if you have bug holes or pinholes or texture, particularly on the picture that we've got there with a timber board profile or pattern on a surface, it looks fantastic, but often there can be voids in the surface, and clear coats don't necessarily bridge or fill a lot of those holes that are there. Bug holes can be quite significant, and if you put a clear coat onto a surface like that with significant bug holes and moisture gets in, or if it gets in, I should say it will get in behind the coating, what you get is unsightly halo effects around where the voids are in the coating, and you can get clouding of the coating occur as well. So we're always a bit cautious to just to point that out before you go plowing ahead and putting a clear coating on Insitu or Precast concrete. And there's just the guide, obviously, for the level of finish for Precast panels. F4 makes us pretty twitchy when we're looking at that and nervous with those kinds of bug holes that are there. F5, we're starting to feel a bit happier about it all, but some of those bug holes that are there can cause problems. And obviously F6 is the thing that has us in a pretty good mood when we see that kind of stuff. And we always love hearing that panels are going to be F6. Right, that's done with concrete. Apologies if there's a lot of info coming through here, but hopefully there's useful stuff coming through. Exterior steel paint systems. Now, all new coatings are based on the AS/NZS 2312 standards. So you will see we're about to show the equivalents, Resene equivalents for the 2312 standards. The other paint manufacturers will have their equivalents, and they'll be very similar types of products and film builds that you'll see here that we're showing you, because we all base our coating systems on the standard. So I thought what we'd do is just give an example of a mild steel system to begin with and the equivalents to the standards. Just as a quick starting point, to select the correct system, first you really need to know the steel that you have. You need to understand the environment, the category, environmental category that the steel is going to be in, and also the length of durability period that you require. All too often we get requests that I've just got some steel, I need a paint system. And so again, we're going to come back to you and ask you what type of steel is it, where is it, what kind of durability period do you require, because it all makes a difference on the paint, on the coating system that we're going to specify for you. Environmental category maps. So I just thought I'd put these in there to show that, and obviously we're well zoomed out on these ones. As you zoom in on it, environmental categories in and around bays and the coastline, there's all sorts of micro climates and different environmental categories as you go on. But this gives a general overview of what we're looking at here today. And I've just highlighted that where you see the green and the lighter green, or the darker green and the lighter green, what it shows us that is actually C3, C4, and we're in both of those areas. The lighter greens are severe, the darker greens are very severe. So pretty much most of what we deal with are severe or very severe corrosivity zones. Obviously, there's a couple of exceptions: Central Plateau, and then Central Otago, and ranging a bit further up there on the South Island. Now, I'm certainly not going to read through this, but this shows us that the definitions for the classifications. And as I mentioned, and someone's been messing around with my presentation, I suspect that was John Kilby. Thank you, John. Most of our environmental categories are C3 and C4, so medium and high. And when you're getting into looking at your categories, and we do get involved in some of these discussions, when you're getting involved in this, you should always defer to the higher category that's being discussed. So you shouldn't try and talk yourself down. You always defer to the higher category. Now this is a guide. This is the coating systems within the guide, and just giving you a simple example here of one of the most common systems that we'll give you, and it's in the polyurethane top coat area. So the PUR systems. Just as a note here as well, as in our conditions in New Zealand, we're typically wanting to put polyurethane type top coats on our exterior steel, and that's because it provides excellent protection, UV protection. Epoxy type systems generally in exterior exposures will have early onset of chalking on the surface, so we're really always looking to put a polyurethane coating on as a top coat. We're just showing you the categories there, C3, C4. Down the bottom there, we're looking at a 25-year durability periods, one of the most common, and that gives us a PUR5 system. And then it's a really simple thing for us to pull out the paint system as you see it. So we're not making these things up as we go. It's really clearly defined what's required. Left-hand side there, the surface preparation, SA2.5 is abrasive blast preparation. Then we're going to put a zinc primer on. We're going to put an epoxy intermediate coat on at 200 microns, and then we're going to put urethane top coats on in the form of Uracryl 403 for this example. So as I mentioned, the other manufacturers are going to provide you with a fairly similar system and at the fairly similar film builds, because it's all based on the 2312 standard. What I thought I'd do here as well is just show you an example of a lesser system and what you get for durability periods. So this is an acrylic system from the standard C3, C4. You'll see very quickly there that the durability period gives you, in a C3 environment, 2 to 5 years, and in a C4 it gives you nothing. And the system that we've got here is power tool prep. Got one of our best single pack steel primers, Galvo 1, and then any of those top coats that you see there as top coats. So when you're trying to talk yourself into just a really basic paint system for exterior steel, you're pretty much not going to get any durability period out of it at all. So that's why we're sticking with 2-pack epoxy and urethane type systems. Key points on this one. So typically, where anything's 2 to 5 years durability period or greater, you're going to require abrasive blast preparation of the steel. And a really important thing for us to point out as well is that for durability periods are time to first major maintenance. So we're talking time to first major repaint. Regular ongoing maintenance should always be carried out. So we're talking about assessing your substrates and actually maintaining them. That starts at year 1. So if you're assessing something, bit of steel, and for some reason there's some corrosion there, you really should be touching it up as you go. Really important note here at the bottom as well. And again, I was dealing with something this morning where we get asked, we get fired in a query on someone else's primers on steel and which one of our top coats can go on. Reality is that we don't test our top coats over anyone else's products, and nor do they test our products. But the building code states that coatings should be from the same supplier and not a combination of suppliers. The reality here is if you have a problem down the track, who deals with it? You've deviated from a specification. When you're combining 2 suppliers' products, you're not following a specification, you're not following the standards, and we don't know how things will perform. We've got a pretty good idea when we see their products or when we read their data sheets, but you really should make sure that you are using the same supplier for your full paint system. That goes for decorative coatings as well, right throughout the industry. So just a quick look at hot dip galv steel, very similar to what we've looked at. There's just one slight difference, or actually not a slight difference, it's quite a big difference. There's the guide that we look at, same C3, C4 categories. And you'll note down there that it's a 15-year durability period, whereas we had 25-year durability period on the mild steel. Now, the reason for that is that we're talking about coatings here, durability periods for the coatings themselves. For mild steel, we blast prepped it and we put a zinc primer on there as the first coat. For hot dip galvanized steel, that zinc coating is already there. That's your galvanizing of the steel. So that does not take into account that in the coating system that's provided here for hot dip galv. We're starting on this one, and in this instance, we're putting an epoxy primer on there as the first coat. The key point with this, though, is hot dip galv steel itself, or the hot dip galv, has a 20 to 30-year durability period by itself, depending on the environmental category and location and exposure. So when you combine that with your paint system, it's a pretty robust and long-term system. So some really key points here as well is that coatings are only one part of the durability of a protective coating system. There's a huge amount that goes into paint systems before you even put the paint on. And so the surface preparation, application, procedures, design of what you've got, the local environments, is a huge amount that influence durabilities of coatings. All too often we're asked, well, I shouldn't say all too often, on occasion we're asked for guarantees for paint systems. Now, when we drill into what you're actually asking for, in a lot of cases, is for us to guarantee the applicator's workmanship. We don't do that. We're not there to see them prepare the surface, to see them apply it, to see the conditions that they apply it in. So your painting contractors, your applicators, should give you their own guarantees, their workmanship guarantees, their PS3 statements, and their quality assurance documents on what they've carried out. they should be measuring their film builds for protective coatings. They should be able to provide you with the measurements and show you that their film builds are meeting the specification that have the specification information. And if we really get down to it, the 2312 standard states that any maximum expected product warranty should only be about 1/4 to 1/3 of the estimated durability period. So if we were doing mold steel and there was a 25-year durability period on it, we're going to give you, just as a product warranty itself, about 5 to 8 years on it. So that's where it would all sit. The reality for steel, though, is most people are comfortable with that the product's applied at the as specified, and they're working towards the durability period. That's what gives the comfort on steel. One point that comes up fairly regularly is canopy situations. This catches people out quite often, actually. Exterior non-rain wash steel is actually in the highest corrosion zone. We want things to be rain washed in exterior situations because it quite simply washes away all of the contamination on the surface, and particularly salt deposits. So in a canopy situation, we're always going to give you the most durable coating system we can. I've seen over the years a number of large commercial, particularly freight buildings that have gone up, and where they've got massive canopies where trucks can drive in and out for the loading bays, and it's been incorrectly specified as being part of the interior of the building. Now it's open at either end and often part way down as well, so it's actually an exterior situation. So seen a number where they've actually had to strip the steel and start it again because they've run the interior paint specification into those canopy situations. So it's one to look out for, and when you're looking at plans, sometimes it's an easy one to miss. Now we're going to have a quick look at timber coatings, and particularly clear film forming polyurethanes. Again, this is going to be covered off very high level, and we'll get into this in a full timber webinar down the track. But we get asked very often about putting clear film forming polyurethanes on timber in New Zealand. We'll quickly cover off penetrating oil stains as well, mineral oils and semi-transparent stains. There's obviously a lot more types of coatings that go on exterior timber, but we'll just have a look at those quickly today. So clear film forming polyurethanes, the story I normally give, which people get sick of hearing, is if I'm lucky enough, or when I'm lucky enough to do a bit of traveling, I can stand out in the sun in Europe for half a day, a full day, and really not burn. I'm about 7.5 minutes, because I'm a white pasty guy, 7.5 minutes here in New Zealand and I'm burnt. So that's basically the same information, same facts that go for our paint coatings here, and in particular clear film forming polyurethanes. They have typically low UV protection. Now, actually, I'll just point out as well before I start, we're not here to bag anyone's products. We're just talking about what we're required to deal with pretty much on a daily basis, and often the things that we go out and look at. There's a whole range of products here, and not here to slate anyone's products. But so what happens is, with low UV protection, the timber breaks down and the coatings will fail fairly quickly. And once the coating starts failing, it's splitting, cracking, peeling, and it can happen in a really short period of time. The image on the right there is a really common thing for us to see. Often products that come to market here are actually developed in other countries for their conditions, and the kicker is they have far less UV impact than we do. There are coatings out there with additional UV stabilizers that often will slow the onset of the issues, but it doesn't stop it occurring here in New Zealand, and that coating breakdown will still occur. So how do you maintain them? Well, what you see on the right-hand side there, you really can't maintain that. It's got to be stripped off and you have to start again. So for that reason, we choose not to have clear exterior film-forming polyurethanes in our range. We develop, manufacture products here for New Zealand conditions. That's the same thing we were just looking at earlier. This seating is approximately 2 years old, and granted, we weren't there, I wasn't there to see it put on and see how many coats they put on. But the reality of it is this is typically what we see when we go out to sites to look at things. Front doors. Now, this is extremely common, and this is a great example of what we look at when we have a look at front doors. And this door is well undercover, but obviously lower down it gets impacted by the sun. And it's exactly the same issue as what we've just been talking about, is that timber fibers are being damaged and the coating's breaking down in that area, and you're getting under film issues around mold and that splitting and peeling. And it's the same issue here. How do you maintain that door? Well, you can't maintain that with a clear polyurethane on it. You've really got to sand it all off. And we would say, you know, it might be a good idea just to paint that door out. So there are some exterior marine grade polyurethanes as well with UV stabilizers. And in fact, our sister company, Altex, has Timber Coat, which is a great product. But you'll see there that when you're using those types of products, they typically require 5 to 9 coats, and they will still weather over time, as I mentioned. What the issue with 5 to 9 coats is when they start going on, once you put 2 or 3 coats on, it actually looks like it's a finished product. And often people don't get past 3 or 4 coats because they think, well, it's looking pretty good now. And as you keep going, the look of the thing doesn't change. So it's really common for people, and when you've got a painter doing it, that you really just don't know how many coats they put on. The other thing is when they're being used in a marine environment, for say a timber yacht or motorboat, people forget that those types of boats come out of the water every year or two and they're maintained, and there's a lot of maintenance that goes on. Anyone that's listening today that's got a boat understands the kind of maintenance that's required. So we all forget about that. We put that same kind of polyurethane on a door like this and then leave it for 5 years, 7 years, and you're going to end up with what you see on screen. It's really similar info for polyurethanes on soffits as well, and everyone thinks, and we all do, they're out of direct UV exposure, but the reality of it is that UV bounces around and it still breaks down the timber fibers. And I took this photo myself, and to be fair, that image looks a little bit better than what it does up close and personal. It's really in quite a bad way, and so we're always a bit cautious to recommend or specify polyurethanes on soffits, and you're going to find that we want to have a discussion with you about your expectation and your client's expectation as well as to how it will perform over time. We'll move on quickly to oil stains. So they're typically plant derived, so they come from linseed oils, flaxseed oils. They give a magnificent deep glow, and they bring out the color of timber. Now, generally, like polyurethanes, they typically have fairly low UV protection, and in fact, some oils can act as feedstocks for mold. So you're actually giving the surface, giving mold some food to grow. So you end up with a higher level of mold growth than what you would using other products or not using anything. So they typically weather very quickly. And again, we see a lot of products here that are developed for other countries' conditions and really not ours. So again, what you see there is a difficult thing to maintain. There's a fair bit of work that will go on there, sanding and then recoating. Reality, that timber would have looked pretty good. That's a new retirement block, and would have looked magnificent being painted out. Probably end up painting it out, to be honest. Where oils get used a lot, and I saw one not so long ago, is when we're using glulam beams as well. And if I remember, I think I've put the slide in here. So I threw this in at the last minute. The glulam beams look magnificent, and often we're now running them from the interior through to the exterior. And I think if you can see on the left of that pic, that actually runs outside there. The intention is to keep that look similar from inside to out, and it's a really difficult thing to do here in New Zealand. So I saw one the other day where interior was looking magnificent with an oil stain on it, and the exterior 3 months later had pretty much weathered off in our conditions. So it's a really tricky thing to keep that same look flowing from interior to exterior, even with other stains that we'll talk about in the next few slides, because quite simply that exterior environment or exterior situation is going to weather very quickly, your interior is not. So we always think the key thing here is to manage the expectation of the client, and what they need to understand is there's regular maintenance for exterior situations, and as you maintain that, that look can change as well, because if you're restaining things on an exterior situation, often you're building up the color over time. So it's all about the expectation of the client. Just thought we'd cover off mineral oil stains here. Now we're talking about the Wood-X type mineral oil stains, and the image that you see there is I think probably the best example of the products or a mineral oil going around at the moment. That's Wynyard Pavilions down on Wynyard Quarter. And mineral oils are different. They are petrochemical based, and they're highly refined. And the key to them is that while they might be touch dry on the surface, they actually never dry. So underneath the surface, they're penetrated well into the timber structure. They're sitting there, they're not dry. They provide a magnificent, vibrant oiled look, and they give fantastic moisture resistance, good fungicides, and in the pigmented options, they provide some resistance to UV as well. But as with all stains, they require regular maintenance. It's generally every 2 summers. So that's again, it's about expectations, and the real key thing to remember with mineral oil stains is that they can't be overcoated with any other type of product. They can only ever be overcoated with themselves or the same type of product. Even then, when they're going on new, there can be a 6 to 24 week period between the first coat and the second coat acceptance. So that's a real key point to understand. Once you put a mineral oil on something, that's all that will ever be on that substrate. That's just a closer look at probably doesn't do it justice. It's a pretty impressive looking building. Semi-transparent stains. So we're talking about products like Resene Woodsman, and they give a more rustic look, and like other stains, they don't form a film on the surface. They're designed to enhance the natural grain of timber and offer some kind of UV protection as well. So semi-transparent stains are designed to erode off the surface naturally. So we do field calls on occasion from people telling us that there's something wrong with our product because it's coming off and the grain of the timber is showing. Well, they're actually designed to do that, to show that natural grain. And again, they require regular maintenance. So exposed elevations typically every 2 summers, and elevations that aren't particularly exposed, actually you can get a fair bit of time out of them if they're not being impacted by the sun. So south side, sometimes you can talk 5 summers. We've seen it even longer. But again, it's really important for people to understand the expectation around maintenance requires. Beauty of semi-transparent stains is surface preparation and recoatings is really quite easy. It's a simple process just to put another coat on. Once they're well weathered, we can offer systems to paint out semi-transparent stains as well. In fact, I've done it myself on my own property, and we have very good success rates with painting over these types of stains. So key point for consideration on this one, and this is the thing we talk about a lot on the phones, we get asked, well, what's the difference between stains and paints? And the key points are Stains and mineral oils require maintenance every 2 to 5 summers, depending on their exposure levels. When we say maintenance, we're talking recoating, repainting, restaining, sorry. Paint coatings, and we haven't talked about those today, but they are typically on cladding systems every 10 to 12 years, depending on the exposure levels. So there's quite a difference in the repainting or restaining periods. And the one thing that we feel sometimes gets missed out is, again, it's about expectation and understanding by yourselves and your clients is the access requirements to do that. If you have a multi-level residential dwelling or commercial building and it's stained, the access requirements to recoat can be quite significant. If you have to rescaffold a house, and we do field these calls regularly, where people are most upset that their 3-level house on the north face sitting in Northland somewhere exposed, that the stain requires restaining every couple of years, and they've got to bring in scaffold to do that. So there's a real expectation and understanding of what maintenance is going to be required when you're choosing your coatings for your properties. So that actually brings us to the end of the FAQs. However, I just wanted to cover off a couple of extra things, given we're trying to minimize personal contact at present. I thought what I'd do here is just show you how a lot of people come to us regularly and ask for drawdowns, and we just thought we'd show you the process on screen here. This was really very much a last minute thing we've added. And so I just thought we'd show you the process of how to order online if you want to cut out a few extra sets of hands in the process. A lot of you come in via our architectural team, and what we do is we get your email, we order them up from Wellington, where our drawdowns department is, and they come to us, we drop them an envelope, we send them out via courier. So we're all cool carrying on with that. However, you can order them directly from our team in Wellington if you wish, and it's a really simple process. So we just thought we'd show this today, and basically just click on colors, order now, order drawdowns, and it's going to ask you to register. Some of you may already be well registered and be doing this. So if you click on the register button, fill in your details. Now I've chopped out half that screen, but the real important area to click on is that you are a Resene professional or specifier. So click the yes button there, and when that registers, what that means is you'll get your drawdowns for free. If you ever have the issue where you're being charged for your drawdowns, then this is the area that's not selected in your login details. That's us done for the day now. Hopefully there's some useful info in there. Please do email through your questions that you may have, and we certainly will come back to you. As mentioned at the top, we're looking to increase the frequency of our webinars now, and particularly in that pre-recorded area for you. And we're really going to try and vary them. And as I mentioned, we may even look at combining with other suppliers as we go through these next 3 to 6 months. So thank you for tuning in, and bye for now.